Hello everyone, my name is Mateusz Pusz. I'm working at EPAM Systems and I'm also a C++ trainer and a consultant. I come to you today because despite being now a member of IC++ committee, a few times in my life, probably similarly to some of you, I was forced to write a code that I wouldn't like to recommend to anyone. And that's one of the cases here. So today I will tell you about my experience in writing and working with physical dimensions, with software handling physical dimensions and units. And I will share you my experience with the software and my, let's say, working progress on the library I'm working as a pet project for now. But first, let's answer the question why we care about this, why it's that important that I will tell about it. Probably you are already aware with Mars Climate Orbiter. Did you heard about it? Yeah, this was a famous disaster. This was a robotic space probe created and launched by NASA in '98. It was worth a lot of money. It was intended to enter the Mars orbit and then do some scientific stuff there. After a few months of flying there, actually, it was planned to be here on this trajectory, and actually it was here. So it turned out that NASA left the radio contact with the probe 49 seconds earlier than they expected. A small error, but at that point they didn't exactly know what's the problem. It turned out that the radio contact was because here is Earth, and it went just out on the other side of the Mars, yes? And it never came out on this way to the Earth again. It turned out that it was so close to the planet here that the gravity force make it like disrupt and yeah, it was disintegrated in the atmospheric pressure and so on. What went wrong? Actually, the problem was that the software for this probe was developed in two different companies. One was NASA, another one was Lockheed Martin. Software specification for this was written in IS units, standard for the international standard for units, SI. And actually, Lockheed Martin implemented this using the United States customary unit system. NASA, on the other hand, also from US, written this according to specification, so in SI units. So specifically, one of the team was providing pound for seconds, another one was requiring Newton seconds from specific measurements, and because of that, we had this really expensive failure in our space travels. Another reason why I care for this personally, a long time ago, in a galaxy far, far away, I was flying gliders on competitions. It was like 3 to 4 years ago. I was a competition pilot flying in sometimes on the flatlands, but sometimes in some dangerous hilly areas, like in Alps, for example. And for that, the part of this talk is concerned about this thing here. This is my car navigation system running some custom software that I was contributing to. The software looks like this one. This is tactical flight computer for gliding and for aviation generally. You can see here that you have some hills here on the map, and this dotted area here is the things that you cannot reach from current altitude because you will hit the hill at some point. So this is really important for all the pilots who are flying with this for competitions or for fun to know exactly if they are safe or not. This is life-critical software, even if it's open source and it's for fun and for gliding. This is another screen of the same size. You want to make sure that you are actually able to go above this hill here when you are going here. This is a glider, yeah? It lands only once. It cannot just try it many times if it fails. So you want to make sure that all of those calculations are great. This is open source project written by like 3 developers right now, or 2. They're doing a great job. I don't want to say or blame them because of what I will show you in a few slides later on. It's just because there is a lot of things to do, and this base of the software was written in C some time ago. So this is, for example, how you calculate the distance and bearing to some to some target. You have latitude, longitude for 2 points, and you provide distance and bearing as doubles. In the same header file, there is another function. Find latitude, longitude from current latitude, longitude, from current bearing and distance when you are going, and these are some outputs. Notice the order in the same header file, and try to make it right every time. Notice that everything is a double here. If you think that it cannot be worse, it can. Try to be correct with every unit here, yes? Wind speed, bearing, some distance, altitude, time to go, and so on. It's really hard to write such a software correctly. Also, such a software makes a lot of conversions between units. It's being done like this one. We shouldn't write the code like this anymore. So, did you ever have to write the code this way? Did you ever have to use like fundamental types instead of, I don't know, price or latitude, longitude, or anything, depending for what your business domain is, yes? I assume that most of us did, and this is a problem. Why do you write the code like this? Because there's no support in the standard library for this one. From my experience working with different companies, I see that Stud Chrono helped a lot for time and duration. Right now, a lot of companies are doing this. Earlier, we didn't use things like this. Date support will come in C++20, so we'll be able to work with calendar. But still, it's not enough for a full dimensional analysis. We have some alternatives, but mostly they provide really poor compilation errors, what we will see in the presentation today. And they have like a lot of dependencies. When you want just to use boost units, you have to like include half of boost in order to work with it. And also, if you're trying to work with some not that known libraries, not like Boost, but maybe some others you will find on GitHub, probably your company will not allow to use it in the production. Because probably in most cases, it's either standard library or Boost, or other are not trusted from GitHub. So you may try to implement this by yourself. For some narrow cases, probably it will not be that bad, but if you would like to write something generic handling several dimensions, then you would like to handle things like force, energy, and other stuff, it turns to be really, really hard to do it correctly. So my presentation today is mostly call for action. I don't have a solution for this yet, but I'm looking for some contributors and help from you guys and from everyone else that's interested in the domain. So what's the current state? Let's review existing solutions. Today we will scope on 2 of them, but before I would like to show you some toy example we'll be working with. This is the simplest thing we can imagine. This is calculating average speed from some length, some time, and returning velocity after division. And you want to pass something like this. 220 kilometers for 2 hours, get the speed with the kilometer per hour unit, or we want to provide miles and hours, we want to have it the same in miles. It has to be compile time safe, so we want to have compilation errors when we provide wrong operation here, saying, sorry, but you are trying to provide me something that is not a velocity to velocity. We want to support multiple units, like here, kilometers, miles, meters, and prefixes. We don't want to have any runtime overhead for this. Yes, we don't want to pay for it. It should be as fast or faster than the things we would write by our hand. And for now, we'll not scope on this I/O output, so that's why I provided this manually here, because this is totally different story for another different talk. We'll scope today on 2 of those. We'll talk about boost units, written by Stephen Watanabe and Mateusz Schabel. It's in Boost for ages right now. And also I found another one, it's by Nick Holthaus. It's pretty modern library, but we'll also see that it also has some issues. So talking about Boost units, in order to start working with Boost, you have to include a lot of header files because it's spread to so many headers. You will be amazed that, for example, you include, even if there is an aggregator saying like SI, and you just have all the SI units there, you still have to provide, for example, quantity as another header, because otherwise the code will compile but will not work or not link. Because there are a lot of forward, like forward, for example, forward declarations, but no implementation, for example. So you have to be careful which headers you include, and there are a lot of them. Moreover, to save space, I just created namespace BU for boost units. And I created a lot of helpers because it's not that easy to work with this library actually. So in order to work with kilometers, you have to create a scaled unit of length, which default is meter, and scale it by 10 times to third power. And then you have a type for the kilometer base unit, and yeah, then I have a unit for length kilometer. I also have to provide some helpers for mile and for an hour because there are none in the standard library, at least I didn't find them. And also some constants that will be used later on. And with that, you want to implement average speed. We can implement this in this way. Use quantity length, quantity time, and return auto for now, because we don't know what to provide here, because we cannot deduce quantity of velocity here. Velocity will not be deduced from the context, yes? But that's too generic. You can provide here energy and power and try to divide it, and maybe it will work. Yes? It doesn't say explicitly that this quantity is length or time. So this is too generic for this case. So let's try to be more specialized here. So you have to provide this long template specialization, where we provide this explicit length, that's time, and you have to deduce all other parameters. But still we're having this auto. We don't know actually if this is really simple, so we know that it should be velocity, yes? But sometimes when you calculate some energy or other stuff that the function will have a lot of mathematical equations there, you want to make sure that you're actually returning what you would like to return from this function. And also for the user to know exactly with which dimension this works. So auto in this case may not be the best one. We can then provide the auto with something called boost unit divide type of helper. When you are dividing current length and the system used for length and time and system for time, but it actually manually repeats all of the built-in logic for dimensional analysis, because you have to say that in order to create velocity, you have to divide those two. So why to use then the framework for this if you have to remember what has to be divided, what has to be multiplied, and so on, in order to create a good return value from it. So for now, let's go on this one because it's the shortest and the most reasonable one. So we would like to now calculate this average speeds for 220 kilometers and 2 hours. And this is how we are doing this. It's pretty good. For miles, it's okay, again, thanks to our helpers that we created. Otherwise, it will be a bit more messy. I don't have more for the slide. Pros of this approach for boost units is basically that it's boost, yes? It's in boost, it's there. Probably we can use it in our products. If we are allowed to use boost, we can use this one. It has a lot of different type systems already, a lot of base units, a lot of physical dimensions already built in. It's flexible extensibility. You can do everything with this. You can provide your own custom systems and much more things that you will ever need to do. It's C++ 11 design, but context was added after that. So most of the functions are context, and they will work in compile time, assuming that the compile time parameters will be provided. And quantity can work from any number with any number as an underlying representation, like Chrono does. So you can provide any double or complex or any number, it will just work with it. Problems with it. It's pre-C++ 11 design. It's heavily it uses preprocessor too much. And there's also a lot of templates from Boost MPL. It's really hard to use. When you want to start working with it, it's not that easy. You have to be both expert in C++ and both expert in the physical units domain in order to be able to work with it effectively. It's because the compile time error messages are really bad. I will show you this in a minute. As you see, there is no easy way to use non-SI units. We had to provide some helpers in order to work with it in a good way. It's spread so for so many header files that it's really hard to find the header file you need for your code. And this is designed on creating unit systems. In most previous talks I've seen about this, most of the presenters said there are some systems in the booth, but I don't know what they are for, but they are there, so I'm telling you about this, yes? Systems are the things that you can, like, for example, divide, said you want to have system with 3 different dimensions only, for example, time and length and maybe some mass, for example. Or you may specify your own system for those 3, but default unit for length will be not meters, but kilometers, and then another system for miles, and you have 2 different systems, one for Europe, one for US, and you have to make sure that you're using different correct systems for correct things. Then maybe those previous slides will be easier to write. So basically, there are a lot of ways to create those systems there. All other libraries I found on the internet and in the community don't have any system approach there. So this is special for this. Another is this units from Nick Holthaus. It is in one header, so totally opposite direction here. It uses literals, so user-defined literals from C++11. Again, to create speed from length and time, we are dividing this. But actually, this time, we cannot specialize more than this. This can work with everything. You can provide int and string here, and it will try to compile that. The only thing that you can provide here as a cipher is static assert, because there are some type traits provided. If it's a length unit or time unit or velocity unit, so you can static assert for this to verify if the input and output actually is okay. But this is not in a function declaration, not in a type, not in the overload resolution rules. It's only in the implementation. Why is that? Because units are defined in that way that they basically inherit from one to another. Like, for example, kilometer is defined as this meter here. This is meter here times 1,000. So there's no one generic thing that you would like to look for this one, because I try to specialize this template and look for this length unit here, but it depends what level of unit it is. This length unit is in a different place in the nesting of templates. So it's not that easy to find it with template specialization here and type deduction. But with type traits, you can actually try to find it somehow. You have more control in type traits. So that's why the type traits here work. Of course, we could try to work with enable if here. Then it will also work here somehow. So we have this solution here. We just provide this with literals. It's simple. We can, if you, for example, we have like variables, we can provide the variable here, A and B, and then provide the types. It will work fine, because you cannot provide actually variables underscore kilometer, because it will not work, yes? But another issue is what Walter Brown noticed me on CPPCon last year when I was sharing the design with him. He said that meter is a unit, not a quantity. We shouldn't say we have mile 14. What does it mean, mile 14? Mile is a unit, not a quantity of length. It's a unit of this, of this dimension. Yes? So basically, you have similar design in Chrono right now. We say seconds 17. Maybe that's because we used to this already, so this doesn't hurt us. But actually, it's probably we can maybe do better than saying seconds 17 or miles 14. A little thing that helps here is that actually it is in a namespace. Those are namespaces. So actually, you know that's length kilometer, not just kilometer. So maybe it helps a bit, but not much. So good things about it, that is in a single header, it's easy to use, but maybe a bit hard to compile every time. The conversions are using stud ratio from the standard library, and we have UDLs. Bad things are, it's really hard to extend this, as we'll see later on. Error messages, again, we'll see later on that are really, really bad. We have only units, we don't have dimensions. And that's why it's really hard to, for example, specialize those templates. And we are mixing quantities with units, and we don't know exactly what is what here. And that's why it's not easy to make a generic programming there. So let's scope on the issues right now. So things that we would like to fix or improve with our modern solution. So coming back to this boost units thing that we created, if I will make an error here and provide multiply instead of divide here, this is the beginning of the error I got. And this is only one line, yes, because this is only error sentence, the one that's really important, because there are a lot of other things there that are not that important. So can you tell me why it failed? Where is the actually dimension here? Is it a velocity? Is it length? And there cannot be nearly nothing that is simpler than velocity. If you try thinking about energy that has like 6 different stuff and 5 different units, or 4, then you will be lost totally in this. And this is only the part, this is the second part of it. Yeah? Try to figure out why it fails, if this is not that trivial like this. With the other library, the units library, the error is really short. It just says, static assert, trade is convertible unit, unit from, unit to, units are not compatible. But which units? What is the problem here? Yes? Sometimes less is worse. Static asserts are really not that useful sometimes for things. First of all, they do not influence the overload resolution process, what we've seen earlier in this. So you can actually put anything here and then it just will not compile. But you can even provide string and int here and it will try to compile that. And for some compilers, you have just this information. I think it's too less to know exactly what's wrong. You just say, it doesn't work, but why? You have to find out by yourself. When you try to debug this, so being in Boost, it's from one IDE I use right now. I don't have much information about the type here. Boost units, unit double, boost unit, unit double, boost unit, unit double. They have the same type for both. When I try to use GDB, I get this breakpoint information. They are certainly not the same, but please tell me how they differ. Here's 10 or 60, probably they are different here, yes? 3, 2, but Similar to the other library, to this units library. Once again, you have unit, double, linear scale, unit, linear scale, double division 220, unit, the same. No information. Breakpoint is a bit shorter, but try to find out if it's a length or speed. It's just stud ratio, stud ratio, stud ratio, stud ratio, stud ratio, a lot of those. Actually, it's not all of them. Sometimes you'll have a lot longer stuff here. Another issue is that there are a lot of macros being used in both of those libraries. I'm sometimes not against macros that much, but probably any library that uses macro for user interface will not be allowed to enter standard library world. So we have to deal with it somehow in different way. This is one library, this is another one, this is the second library. All of them are macro-based. At least for now, but probably they can be rewritten like without them. Extensibility. Adding direct dimensions, so dimensions that already use the base dimensions like length, time, mass, is pretty easy in all the cases. But if you would like to introduce a new base dimension, like, I don't know, for bits or something like that, they have it, but maybe you will have some base dimension you would like to add to those, it's pretty hard. For boost units, the approach is that base dimensions are just using the identifiers here. They have to be unique, and this uniqueness is checked during the compilation time. Boost uses negative values, users can use positive values here. But let's imagine we have vendor 1, vendor 2, they are both building the libraries based on boost units, and then there's vendor 3 that wants to use both of them, and all of them started from 1, yes? And you have problem, because the identifiers will collide, you have to rewrite all of the software from one vendor. Another approach of units is just to provide in the base unit ratios for all of the base stuff here. That's why we see so many ratios in the error log. But the issue is there, if you would like to add one more, you have to rewrite all of the base units, base unit implementation, all of the predefined types there, all of the types you have and other vendors have, because this is the base type for everything in this library. So actually you cannot add anything here, yes? But you can see there is a byte here besides the 7 standard SI units here. So they added something, so this may be more common for our usage, but if you find something that you would like to add, it's not that easy. So let's keep the things that I have experience with, that I play with as a toy project. It's still a work in progress, so it's in any way stable or backward compatible. So I don't recommend you to use it, but you can welcome to go there, read the design in the README, and play with it. What are the requirements for it? First of all, safety and performance. We have to use strong types. We will have a lot of template metaprogramming there. We have to context all of the things. I want to provide the best user experience because I want to make every people here in this room and in the world being like happy working with this library actually, yes. So I put a lot of effort to make it user friendly. So I'm talking about the compiler errors and debugging. There cannot be macros, no external dependencies besides standard library, easy to extend, and this is because at some point maybe me and contributors I will find, maybe we'll propose it for the standard library. So I will not talk about the design right now because we don't have time, we have only 45 minutes, so I will scope only on the points that are really interesting here. If you would like to read about the design about it, it's in the markdown on the website. You can find the detailed design, the description there. So talking about extensibility, we have something like a base dimension. Base dimensions in my library are defined right now by this dimension identifier that is just an integral constant. So this is the same approach that Boost uses. 0, 1, 2, the same problem with collisions when two vendors are using this, yes? So how to approach that? C++20 in the paper 7.3.2 adds class types in non-type template parameters. It would allow us to put, right now you can only just put things like int, maybe enum, to a template parameter as a value, not as a type. Yes? With C++20, we'll be able to put any trivial class that will work with default generated Starship operator to compare it for equality. So that's exactly what we need. We want to have unique identifiers that can be compared one with each other and actually ordered. So this is exactly the requirement for this type. So let's try to use it. Oh, it looks like this. For example, you will be able to write a fixed string as a value parameter for a template, and then just write entity hello. It will be special instance of this class template for this string literal. So let's try to use it. Let's make our base dimension a fixed string or any other type that we'll invent for this one. For example, we may have like 2 fixed strings. One will be the length, another one will be like user or vendor namespace. So they will not collide even if 2 vendors will end up with the same name, for example. So for example, it can look like this. Based in length will be length, based in type will be time. If you want to add anything by yourself, you would add something that will probably not collide with this at all. If 2 vendors will be adding those, probably will not collide unless they will provide exactly the same physical dimension, which is actually good that they will collide because your 2 different implementations will be compatible with each other. So for extensibility, I think that features may really help from C++20. Let's try to handle user experience here. We have those generic programming issues, so how to specify velocity as a return type, and how to specify those types for some libraries, compile time errors, and debugging. So you probably remember those 2 for Boost units and units. We had here this really generic stuff with static asserts. We have here the Boost units stuff with auto, and how to deal with it. Actually, C++ concepts are really stuff that helps here. If you defined quantity of in Boost units using this type trait that they provide, is quantity of dimension, you can provide 3 different concepts for length, for time, and for velocity. Quantity of the length, time, velocity. You have 3 concepts, and you write code like this one. This is how you'll be able to write templates in C++20 with constraints. So these are like generic lambdas with constraints. The syntax is really similar. So this is a template that has 2 parameters, length and time. These are deduced, but constrained that they actually have to be length and time. And we have velocity here. Look that we can actually deduce the type here, or verify the type that we couldn't earlier, because we know that it has, what is written here, it has to meet velocity concept, so it has to meet this, this type trait. So right now, it turns to be really easy. Let's look about on the other case, when you have those nested types. Actually, as I told you, we had those static asserts that were dealing with this nested type, and we are just using those the same way. Length, time, velocity. And what's more fun here is that we ended up exactly with the same signature implementation for both libraries. So you just may have different header files with different specifications of the concepts, and you have the same implementation for both. Concepts actually are not only the only the helpers for lazy developers that they are helping you writing things that you can write already by yourself. As you've seen, we've solved some problems that we couldn't right now. Besides, for example, let's try to constrain class template with enable if, for example. Probably it will not be that easy. And you can do this for class templates. It's easy to do this with return types, yes, which was not also that easy in the previous cases. So actually, it helps a lot in different things, so I decided to use it for everything in my library. Even in places where actually only the type deduction would work in typical ways when I will provide just template specialization here with some types to be deduced. Yeah, so let's go again to our pet example with velocity, which is actually the simplest derived dimension that you can imagine. We have, this is how I will be doing this in my library. I just say that's exponent of length to 1 and base dimension time to -1. And I have some special case here, make dimension, which I will describe you in a minute. Type aliases, names are lost quickly when you are using type aliases here. So after a while, probably after 1 function or 2, maybe those aliases will be lost, and you will end up with such a type, either in an error log or in a debugger or anywhere else, in a different place in your code. It's really pity that we still don't have strong typeless in our language. We tried several times, and we failed every time to do it. Maybe at some point we'll have strong types, so we'll just have some special syntax saying this is exactly behaving like this, but it is strong type, not just an alias to a different type. But right now we don't have a support for this. So how to deal with it? I decided to go with strong typing and inheritance. This will never vanish in the compilation process, but it has some issues, yes? First of all, it will not be easily applicable to not simple classes. If you have some class with some logic, with some constructors, equality comparisons, and other stuff, it will not work for you, because you have to rewrite those or use CRTP in some cases, just to provide here the type of that type, so all of the operations will be, for comparisons, for example, will be implemented in terms of this type, not the base type. But this is only the case for quantity in my library, and quantity anyway, if I will even provide the alias velocity, I still mean that quantity of dimension velocity. It's not like velocity is some specific type. It's still a quantity of velocity. I just don't want to type as much. So in this case, alias works for me. But still, I'm considering this. Maybe it will be needed or refactored at some point. So this is how it looks. If you have alias. Okay, and if you have alias, actually it should be alias. Yeah, it's an alias, but here you're using the strong type for velocity. This is strong type already. This is not an alias. So here we are dividing the stuff. And we have right now a problem. How to go from the length and time, so we have two different dimensions, go to dimension velocity, which is a new type, yes? We have here length and type here, but we just created a new type. We have to upcast the result of this operator for division. So it has to find out that from those two, it has to produce two different type, not just an alias that mixes those two somehow in the middle. For that, I will be using also a new feature from C++20. It's a type identity type trait that is known from many libraries. It just provides types. Like this, all type traits have you have two types of type traits. Either they will provide a value or type. They either have _t, _v, yes? And those with _t can be written in terms of type identity, all of them. It's exactly the same pattern. It is just a simple struct that has type equals to the type provided here. So my upcasting trait will use type identity of t. So there will be type equals t inside this implementation. I provided upcast base as a base class for everything that can be upcasted, and it provides base type as a type. And for example, dimension inherits from the upcast base dimension of this type. So exactly from this. So this is CRTP pattern. Yes? Are we still together? Okay. So right now we have this dimension velocity. We have make dimension, dim length, dim time. We created a strong type here. And this result of it, make dimension, will be dimension, which has a base type here. So what I actually can do, I can say that my base type will be dimension velocity base type, because this is the thing that is here. This base type, yes, it was in upcast, this thing in upcast base. And I can specialize my upcasting traits. Every time you see stuff like length time, converted the type, upcast the type to velocity. So this is doing upcasting in compile time, because it will know exactly what is the time of those two. It may be a bit controversial approach and a bit verbose to type in my implementation. I consider still to go with CRTP with this one, but then all of my types, like dimension, unit, and everything will have additional parameters saying what type of child class is connected with those. So in every error log, every debugger will always see this type that inherits from it. So with that, coming from this, we will have this everywhere in our compilation, errors, and debugging stuff. You will have information that you are working with type with D, which is quantity of dimension velocity, with units kilometer per hour, and you're working actually with long int. I think that's a nice improvement from this type. So how it helps you with the compilation stuff? We have the same written here with this error. It actually is much shorter than the previous cases, but still has some duplication here, because we provide dimension twice. This is my design decision that I made, but I'm still considering going back from this. So basically I provide that quantity has to have the same dimension that the unit does. So I can say that it's a quantity of length, and kilometer per hour or kilometer has to be a unit of length too. And that's why it's divided here. And we cannot construct meter from this, because it will not be meter per, or this will be like kilometer per hour or meter per second, because this is actually the error here, yes? So there is no type that was registered in this upcasting traits for such specialization, because this is wrong specialization. So if you will mess up, you will still end up with the long stuff here. But what's good type is say that you cannot cast it to units kilometer per hour and not just another long stuff. because this is known, this is already a strong type in the library. Because otherwise you will have this one and another one here. But actually, I'm not having this implementation here, returning velocity of kilometers per hour, because I don't know what will be provided here. I'm having this velocity auto. And I wanted to show you how the actual errors will look. So they will be working with concepts. I don't know if you already played with concepts, as you see how they provide error logs. So that I wanted to show you all of the error log that we'll get from the compiler. Compiler will say that here we have a problem because constraints are not satisfied. We'll have information that this concept velocity have some issues. The velocity is defined as quantity because every velocity has to be quantity in my library. And actually, as I told you, the type here has to match. So we have to have the same dimension. So the t here has to be of velocity because this is velocity. Same is implemented as meta same in the library from Casey Carter. I expect to be maybe better or less variables in the standard library. And it checks in both directions, u and t and u, if those types are the same. And we get information that we have type units dimension velocity and units dimension dim length to first exponent and time to first exponent, and they are not the same. Bool evaluated to false. And this is the rest for the reversed case. So t and u are reversed here because of this case, yes? I hope that even for those compilers and libraries will be written in order to optimize those errors, probably they will be even more user-friendly. Talking about the debugging, right now in the IDE, I see exactly what I'm working with. I see that d is a dimension length, kilometer, dimension time is hour. I know exactly that's working with doubles here. I know everything from the debugger, but anyway, I will show you the breakpoint from the GDB. It's still pretty nice, saying kilometer, double, time, hour. We have all the information needed here. So coming back to our toy example, how we can implement this in library I write right now. You can either provide this thing that's really similar to the second library we've seen. If you have like variables instead of values, you can use those for variables. You have to provide that units length of kilometer, units time of hour, and this is the type you are using. As you remember, this length and time are aliases for quantity of base dimension length. Okay, so there's one more feature I wanted to talk about you today, is CTAD, class template argument deduction, that was introduced in C++ 17. For example, if you have a vector, you can write a vector this way. It will automatically deduce that it's a vector of int, and it will deduce also the type from the iterators being used here. But actually, if you provide alias, and you have such an alias in C++ 17 for polymorphic allocators, this code will not work this way. We'll have to provide all of the types here because we don't have CTAD for aliases. Thanks to Timur here, we'll have this fixed in C++ 20, and other guys too, not only Timur, but Timur was one of the contributors to this. It will work also for aliases. And thanks to this, my quantities start to work correctly for C++ 20, sorry. So we have this alias here. Length is a quantity of dimension length, and we have then unit and representation. So we can write things like units length d1 free. It means that you want to use length with default unit, so meters, and the representation will be int. If we write the same one with double, we'll have double. Actually, because on the last meeting, some stuff on or the previous one, some stuff didn't pass, this thing will not work. So if you write units mile, so you will specialize only the first one, then the second one will not be deduced from this, but will be used the default. So this will end up with double, not with int. But this one will be double. And if you provide float, it will be float, of course. Workaround for this would be to provide another alias, and work in the similar way that the Nick library does, or stud ratio or stud chrono right now does, saying that length miles is length of mile and the representation. And in such case, the same code as here will work correctly, which for me is a strange thing that it doesn't work, this works, and this is exactly the same thing. Here I'm fixing the mile explicitly, and here I'm fixing the mile with alias definition. In my opinion, it's not consistent because it shouldn't matter if I fix it with alias or should I fix it with implementation here. It's the same fixed first type and second time in this case will be deduced, in this case will not be deduced, which I think is wrong. But this is my opinion. And maybe you should think how to fix this. Because I really wouldn't like to provide aliases for every unit in my library. Another feature, probably the last one, are contracts. Contracts can be expressed in that way right now, using GSL, for example, saying this is contract for this division operation, so division cannot divide by 0, so we take this second type, compare to 0, and we see that have a compile error, saying that macro expects requires one argument, it took 3 because we have commas here. Yes, so what I can do, I can provide helper type here and provide this type here. But it doesn't, it's not nice for expects. I can also make something like this, remove CVRFT, which will be in C++20, or right now do DK, it's nearly the same, and do decal type right-hand side and compare it to 0. Anyway, it's still wrong, because we are using macros in header file, which macros are wrong, and in header file are even worse, considering possible issues with ODR, one definition rule. And they are not a part of the function signature. So if you have on the declaration, we don't know about the contract of this function. So in C++20, you will have contracts. We can say expects or pre, like Adrian said in the morning. We'll see which version will win. And you can go back again to this full syntax because it will not have any problems with macros, as we had with macros. I have a lot of open design questions. Those are only 5, but I have like nearly 20 right now on my website. You can find them on my repository. I'm still thinking how to solve this in the best way, what are the best way to solve it, and I'm looking for contributors. So if you would like to help, I'm open to any help with this one and for any comments and suggestions. I think that we really need a physical units library in the standard library. Why to join? Industry and community needs it. It's a great opportunity to learn C++20 because it will be heavy C++20 feature of features. And I think it's an interesting and hard challenge to solve. I like challenges, so that's why I'm doing this. So please help. Do you have any questions? If not, thank you very much.